Hello everyone, welcome back to the channel. Today, we explore how a precision strike eliminated Ahmed al-Rahawi and why Iran and the Houthis have immediately vowed retaliation. At the most basic level, the incident hinges on guided munitions and intelligence coordination. Israel reportedly deployed advanced air-launched missiles, likely variants of the Delilah or Popeye cruise systems, to strike a high-value target deep inside territory. Such missiles rely on GPS and inertial navigation, sometimes enhanced by electro-optical seekers for terminal accuracy, enabling pinpoint strikes even in cluttered environments. Iran and Houthi forces quickly cited this as a strategic provocation, signaling they will leverage their own missile and drone networks for reprisal. That means overhead analysis of launch capabilities is now critical, as well as understanding command and control links, satellite relays, and long-range guidance systems, all foundational to grasp this high-stakes exchange. Now, let's build on that foundation. Iran's missile arsenal includes the Fatih 110 short-range ballistic missile and its upgraded M600 variant, capable of hitting targets hundreds of kilometers away with high accuracy. These use inertial guidance paired with terminal systems like electro-optical seekers or GPS arrays. Meanwhile, the Houthis have adopted Iranian-supplied Quds-1 and Birkin series rockets, and increasingly deadly drones like the Samad-3 or Qasif 2K, blending loitering capabilities with one-way kamikaze strikes. Their innovation lies in simplicity and adaptability, using rudimentary propulsion and GPS components scavenged or smuggled. Yet, when deployed in mass or combined with decoys, they can overwhelm air defenses. So as Iran and the Houthis prepare retaliation, we expect to see a blending of guided missiles, drone swarms, and electronic disruptions, laying the foundation for a multi-vector, technology-driven escalation. Taking it up a notch, let's talk about the technological interplay, intelligence, surveillance, reconnaissance. Israel likely relied on real-time satellite feeds and signals intelligence, SIGINT, to track al-Rahawi's movements. Drones like Hermes 900 or West Bank platforms provided persistent ISR, relaying video and infrared data. On the other side, Iran and the Houthis tapped their own radars and CGINT arrays to counter these eyes in the sky, often jamming or feeding false trails. In particular, Iranian radar systems such as the Mersad-M and Bavar 373 can detect and track drones, while Houthi forces use portable radar offshoots to cue missile launches. The key in this retaliation theater will be who can maintain sensor superiority, whether via stealth lanes, anti-radar coatings, or autonomous drone flocks that act as electronic decoys. The next phase could see drones so numerous that air defense systems struggle to discriminate real threats from false targets. Next, consider command and control architecture. Israel's military uses the C4I command, control, communications, computers, and intelligence backbone, integrating satellite communications, secure data links, and automated strike planning that allows rapid authorization and targeting. Conversely, Iran and Houthi networks, though less advanced, are surprisingly resilient. They employ mesh-networked radio systems, encrypted satellite uplinks, and even civilian telecom infrastructure to coordinate attacks. Combined with field-level autonomy, local commanders granted latitude to loiter, surveil, and strike, this creates a flexible, decentralized response. In a retaliation scenario, that means missile and drone deployment won't follow centralized timelines. Rather, spontaneous launches from dispersed mobile units could complicate interception. Understanding these command frameworks shows why defending against irregular missile waves is more than just shooting missiles. It's a race of information and control in contested space. Moving forward, let's examine logistics and force sustainment. Israel's strike precision comes from decades of supply chain security, advanced manufacturing, and precision warhead engineering. For retaliation, Iran and the Houthis rely on clandestine shipments through land and sea routes, using concealment techniques and shadow networks. Components like detonators, rocket fuel precursors, guidance modules, and drone parts are smuggled, sometimes via drones, boats, or improvised tunnels. Iran's domestic arms industry allows field, repairable missile systems with rapid turnaround on launch vehicles. Houthi forces augment that by repurposing civilian UAVs and retrofitting warheads. The technological counterplay becomes clear. Israeli forces will seek to interdict these supply lines via surveillance and special ops, while retaliation forces invest in hardened manufacturing caches and dispersed launch sites, making supply more resilient. This interplay defines escalating risks of intermittent bombardment vs. rapid counterstrike launch. Let's elevate to electronic warfare. Israel's defenses include systems like the Iron Dome, David's Sling, and Arrow, backed by robust EW suits that intercept and jam radar and communication signals. Iran and the Houthis may not match this digitally, but they excel in low-cost jamming, GPS spoofing, and signal denial tactics. They've previously masked drone flights using frequency hopping and decoy broadcasts to confuse tracking sensors. In this upcoming clash, we may witness counter-jamming or anti-jam tools in action. Israel might deploy adaptive beamforming and filter algorithms, while retaliation forces use layered jammers and decoy drones. The result is an electronic battlefield where missile guidance and drone navigation become fragile, contested commodities. Success hinges on which side can preserve signal integrity under barrage. Now, let's dig into missile and drone hardware enhancements. Iran has progressively improved baseline missiles, adding maneuverable re-entry vehicles, composite propellants, and thrust vector control, yielding greater accuracy and range. The Houthis, meanwhile, innovate in swarm tactics, packing dozens of small drones with high explosive warheads to synchronize timed strikes. These drones can be launched from coastal zones, blending flight patterns to saturate defenses. In retaliation mode, expect layered attacks, first wave of decoy drones, second wave of missiles, followed by precision, guided UAVs targeting radar and communication nodes. This sequential barrage combines cost-effective hardware with time-critical precision. Such a layered, multi-axis assault raises the technical stakes dramatically, a battle not just of weapons, but of timing, deception, and coordination. Pushing into advanced territory, let's consider autonomy and AI. Israel may deploy AI-assisted tracking systems that analyze radar and video feeds to accelerate target identification and missile interception. Iran and the Houthis, though limited in resources, have increasingly added open-source autopilot kits, lightweight AI modules, and flight path optimization algorithms to drone controllers. In a confrontation here, we might see AI-guided drones that evade air defenses through dynamic flight adjustments. Unlike scripted paths, they adapt mid-mission to radar threats. Israeli defenses may counter with AI-driven intercept solutions, adjusting interceptor trajectories in real time. This technological chess game, autonomous drones vs adaptive defenses, ushers military technology into a new era of real-time decision loops, where milliseconds count and human intervention plays second fiddle. Nearly at the frontier, let's talk about future-class systems, hypersonic and directed energy weapons. While these aren't yet confirmed in the strike reprisal cycle, both sides aspire to integrate them. Iran has reportedly experimented with hypersonic delivery vehicles and pulse laser prototypes. Israel is advancing in directed energy systems for point defense. If retaliation escalates further, a preview of these Cold War-style technologies could surface: hypersonic missiles launching from mountain bases, or laser arrays intercepting incoming drones. The symbolic power alone would shift regional balances. For now, these remain at concept or early test phases, but the eyes are already trained for the first test intercept or hypersonic launch, because once unleashed, such tech redefines retaliation thresholds. Finally, bringing it all together, the strategic and technological implications. The strike that killed Ahmed al-Rahawi and the subsequent pledges of retaliation are more than just one-off events. They signal an accelerated arms race in asymmetric warfare. Precision, guided missiles, drone swarms, EW tactics, AI autonomy, and next-gen systems For watchers and analysts, the key takeaways are clear sensor superiority, control, network resilience, manufacturing stealth, and adaptive response will determine who holds battlefield momentum. As Iran and the Houthis mobilize their asymmetric arsenals, Israel refines its layered defenses and AI integration, keeping an eye on supply routes, drone swarm tactics, and AI. Enhanced targeting will offer early clues to how this confrontation evolves, and whether it remains contained or cascades into a broader regional arms escalation. Stay tuned, stay informed, and subscribe for real-time military tech updates.